Good afternoon, ladies and gentlemen, and welcome to this MasterSeries PowerPad webinar. My name's Tommy White, and I'm one of the developers of the MasterSeries. So, the real question we want to ask first of all is, what is PowerPad? So if I can actually just get my slideshow to work. PowerPad, it's not one program, but a complete integrated software suite. It is not a little group of spreadsheets, pro formas. It is real structural engineering programs. It is in fact versions of all of the main core programs from analysis and design. It is this reuse of the existing MasterSeries programs that makes PowerPad so useful and powerful. And PowerPad is fully upgradable, so it's not a cul-de-sac, it's not a dead end. You can upgrade from PowerPad to our big multi-story stuff at any stage, and you will get credit for your PowerPad system. It consists of modeling programs such as MasterFrame, our frame analysis engine for plane space frame grillages. As you can see from this little nice image, it's a multi-material program. We also have our MasterPort Lite, our elastoplastic portal frame analysis program. And then you have your simple beam design programs. Integrated into these is your steel design for designing your steel members in your simple beams, in your trusses, in your multi-story frames, in your portal frames. Concrete design for doing your concrete beams, your pad foundations, your columns. And timber design, and we can do standalone or integrated timber design. And also straight through our connection design, as we can see here, doing a two-way connection. We also then complement all this with a whole range of our independent programs, such as the masonry design for designing masonry walls, our retaining walls program, and our composite beam design, and finally our pile cap program. So what are the benefits that we will see? We will see that it's a fully integrated system, one system for steel, concrete, timber, all in one structural model. There's no repetitive input between programs, so the steel design takes all its data from the frame analysis or from MasterPort. And it's obviously very accurate, gives you a good assessment of a real model and gives you all the correct design. Also, being the MasterSeries, it is not a black box. You are in full control of the design, and with it being all from the one supplier and using the one group of programs, it's got a common interface, which means your learning is short. Learn one and learn them all. So I'm just going to come out of that, and I am going to start the MasterSeries. So MasterSeries 2014. So let's continue on and just go in and look at probably the core program to the whole PowerPad, the whole MasterSeries, is MasterFrame. So frames, MasterFrame, and I'm in the Master Demo PowerPad directory. So I've pulled up here some frames. So we can do simple beams, we can do A-frames, multiple beams, trusses, another truss, quite complicated, a nice curved truss, ground beams in concrete, so you can do some lovely ground beams on piled supports, simple or not so simple plane frames, towers, concrete. So we will be looking at this concrete frame. We can even model in MasterFrame our portals if you so desire, although we do have a dedicated portal program for you, the MasterPort Lite. And then we have our typical multi-material frame. And obviously the more unusual industrial type buildings. I think this is some sort of crane frame. And this is an example one of our clients sent us of a little house that was being generated, and staircases. So the range of material, of geometric shapes that you can do is vast. 2D and 3D. Beams, frames, trusses, fixed, simply supported. It's all up to you. So if I go into this little timber truss, I want to just open this file up, and we can see it's a nice timber truss in 3D. Looks nice. And I'm just going to turn off my 3D graphics so I can see my frame just nice and neatly. So obviously you're going to have your coordinates as an 8-meter truss. You're going to have your member numbers. You're going to have your section sizes, a 47 by 72 C20 timber. So we've got all our different materials built in. Just turn those off. We can see our member connectivity. He's just analyzed this as a fully rigid frame. If he chooses at analysis time to do it as a truss analysis, it will at that point do it as a pinned frame for him rather than having to go in and put in the nodes and everything manually, or the releases. What I want to show you in here is the editor. And the editor is very logically set out. You have your geometry, you have your viewing tools, your section properties, and then you have your loads and restraints. So what we won't have access to is the 3D model manager, because we don't have that in PowerPad. FE editor we won't have. Obviously you could add in the model manager or the FE as additional upgrades if you so required. So in the editor I can naturally zoom in and out, I can rotate my frame, I can have fun, but the real important thing is adding members. Now if I wanted to add, for whatever reason, a column down here, I would just go to geometry, define new member, and lo and behold I can snap onto that node and I can come down. And you'll see right away that we're getting some interesting things happening. In this example, I'm coming perpendicular to that cyan member and I'm coming as a projection from that dark green member. So we've got some really fancy automatic snapping for you. What I'm going to do is I'm going to hover and grab that as a component, and then I'm just going to come straight down and put my member in. Now I was messing around there and I didn't quite get it right because of this little member here. I should have gone in and removed some more of my snap options. But those little pesky items are quite useful. If I wanted to create a member up as a continuation, I can do so. So that is now a continuation up on that line, and then I have this as a continuation. If I wanted to continue up here as a continuation, that's no problem, continuing up from that and snapping on. I can hover over this and then I can come parallel to that member instead, which is at a slightly different angle, and snap on. So in this case I am not continuing that, but I'm parallel to that one, and obviously I will have my other simple snaps. Now one of the more simple options you have is the ability to take a node and just say, right, I want it to be 2.117 meters in that direction, just like a certain CAD program. And I now want to go vertically up 4.44 meters and then come across. So I could come straight across from there and I could snap perpendicular if I'm zoomed in enough to catch the perpendicular point and take it off. So it is very easy to create members. I'm just going to do a quick couple of undos because I'm going to come back. And for those who are asking the simple question, I can hear George typing away there. Can you also put in coordinates? Yes, you can. There is no problem putting in coordinates. I could go and I could define new nodes. So I could go into my coordinate list and I could say, give me a new coordinate at 3 meters and 4.4. And there we go. We added a new node at that coordinate, and then we can just go and snap between it to draw our member lines. Very, very simple, very easy to use. We naturally have all our section properties, so if we come down and look at our sections, and we look at this member, we'll see we're using timber, and it's a C20 grade. We can also have it to be a steel prismatic section or a concrete prismatic section. So we would have a concrete rectangular section if it's so required. Steel sections are where we have the most flexibility. Obviously a 1016 section is not exactly right for this truss. If you're doing it as a UB, you might decide to drop that right the way down to a wee 127 by 76. We naturally have all the UBs, UCs, RSJs. We have flat, round and square bars. You have your universal bearing piles, which are quite unusual to be used these days. Then you have the European sections and American sections. You can also create your own groups of sections, and somebody has already created a group called UB1, and he's created his own definition of section in there. Then you follow through to the hollow sections and the angles, channels and tees. And then you have parallel flange channels and the old-fashioned tapered channels, and then into the split tees afterwards, as well as your angles that we were talking about. So you do have recourse to a whole series of sections. Now, if I went back up to a UB and I came back down to a nice smallish one, we can see that section. I'm just going to zoom in on this area for you, just so you can see it. Okay, I know it's in a truss. But for these ice sections, we also have a whole lot of extras we can do. We can make them haunched. So we could come along and make it haunched so that we say we have 0.5 of a meter. What length is this? Oh, it's a meter long. So I'm going to say 0.25 of a meter, and then 0.25 of a meter, and we'll have it 1 times the serial depth and 1 times the serial depth. So it shows nothing. That doesn't make sense. 2 times the serial depth and 1.5 times. So we can create a haunched member, and that will be analyzed and structurally designed. So we have double haunches, we have single haunches, and we have prismatic members, the normal section. We can also do double sections, so for those little areas where you need to share the load between 2 members, instead of having to half everything, put in a double section. We can also, with our prismatic member, go for a casing. So I can say give me 50 all round, and it's giving me the 50 all round casing, and it's using 30 Newton. Now, for a beam, that's going to improve your radius of gyration. If it was a column, designed as a column, then we improve the compression of the member. What else do we have? Let's get rid of our casing. We can have built-up sections. So we can have a section. Let's put this into an 3D orientation. It looks nicer. And I'm going to put a bottom plate of 12 mil. That is going to be 200 wide. So there's my bottom plate, 200 wide, and it's going to be projecting just on this side, so 200 and sticking out. Or we can say, well, whatever it is, we need a 100 mil projection, and it calculates the size of the plate. So it's a 201.9, so probably a 202 would be more sensible, or even a 200. As well as plates, we can add an additional section. So I can now stick a little section onto the side of that, and we now have a compound section that has a plate and, as you can see here, a section into the side of that section. So very complex additional plating is possible. And finally, we can come in, and possibly not that intelligent in here, is to ask for cellular openings in the section. Now this is so short you're probably not going to see them. I'll come back to that when I go into a different frame. So that's your properties, and then we'll look at loading. Loading's dead easy. Remember loading. Let's pull ourselves right out, and we can see that we're looking at a 2 kilonewton plus a 2 kilonewton dead and live on each of these members. And what does that really look like? Well, if we load our diagram, we'll see that we've got our live loads which are applied horizontally, and our dead loads that are applied, in this case, onto the members. And we can create different loading groups and loading combinations to suit. Now, I want to come out of this because I don't want to dwell too much on any one program, because I have a lot of programs to get through, and I'm going to open up a different file. I'm going to pull in this little frame. It's in steel, it's in concrete, and it's continuous and simply supported. So I look at my support conditions, I can see pins across here, but in fact somebody's been nasty, and this is a continuation here. So what I would need to do in here is to make sure that this member, and we've got a support here that's continuous, so this is continuous all the way across, whereas this one's simply supported, and as is the other more sensible members are simply supported. But we've just done some unusual things for the fun of it. If I analyze this frame, we've got a whole lot of loading cases. We've got P-delta analysis applied. In this case, no plastic. And since we're in PowerPad, we don't get seismic or dynamic. They are extra programs. And we've got notional horizontal analysis. Space frame, let's analyze. And there we're done. So let's go into output, graphical. Bending moment diagrams. Whoa, let's take off the 3D. Come back out a wee bit, and I will see my big frames and everything. So what I can do is I can come in and I can say, well, let's just have a look at this side of the frame. And I can then view and see, and I can scale down. And another trick is I have filters, so I can say don't show me horizontals. So if I can say everything but horizontals, then we will see the portal that's around that. So I can filter out to my heart's content the objects and the areas in the frame that I want to see. So if I come back out to the full frame, I can change my resolutions and my scaling. I can ask it for values. I can ask it just for the major axis values. I can come along, and I have already created some named views. I can look at the front view and see all my forces coming through there. I can look at all the loading cases. So let's look at the ultimate cases, and I can see my envelope of results. I can see my axial loads in my members. If there was any torsion, which I hope there's very little torsion, a wee bit of torsion running around due to fixity of beams. Shearing diagrams, deflections, whoops, a lot of rotation there because we've pinned these up here, and then deflection with geometry, and it's telling us that we've got these deflections. So you have the full access to all the results. And what I'm going to do is, just as I work through this seminar today, is I'm going to print some data out. So I'm just going to take a wee 3D view, put some section sizes on it, and print this. So I'm just going to go right mouse click, print, and I'm going to print straight to a PDF writer. And I'll put this first page out in landscape, and I'm going to give it my X and Y coordinates. So we have a degree of scale as well. And I'm going to say print. So that's now trundled off to my PDF writer, and we'll see all the results at the very end of the frame, of the session. Back out to 3D. Let's go and look not just at that, but at the full frame. Take off all this and do another nice picture. Print graphics. This time in portrait. And print. So again, it's running through and grabbing the images, building them up as a tile, and out we go. Output, tabular output is all available, as is detailed output. And I'm just going to print out some loading cases here by default, and I'm just going to print to the printer these. So I should end up with another 30 pages of output. If I wanted to view the tabular output, I can come along and look at my deflections, my member forces, and look at the maximum values, and a full inquiry there. So we've analysed the frame. We're happy with the bending moments, the shear forces, deflections. Now I've already taken 30 minutes up and I'm still just in the frame analysis. So let's get on. Design, steel design. We can integrate it, come straight through into the design. And I can take any particular member, one of these wee trimming members, and I can see to the Eurocode that it was a compound section, the plate girder, and it's actually working fine. It's actually very under stress because the load has not been applied to it. Look at this member, it's fine. This one, we have quite a lot of bending moment on it. It's just been, the convention has just been changed to draw it upside down. I'll leave that at the moment. I haven't time to go and correct that. And I can see that we're quite close and we have a 74% unity value. So would a lighter section work? Well, I can drop down by section size and say, oh, that doesn't work. Oh, there's the 60 that works, and it's very close because obviously the beam is restrained, so it's only, in this case, it's a fully restrained design, and it's only the local capacity that's important. But I can also ask it to first of all sort these by weight order and then auto size and see if I get a lighter section. I got a slightly deeper section, same weight, 60 kilogram, that worked, so I am not as close to unity, and that is a simple design. So let's look, what else do we have? Any bracing members? We've got a little strut and tie on my bracing member, and if I just turn off the 3D, it's actually quite useful because it lets you see just that current member in more detail, and we can see that our 142, if I want to come down, try an 89 by 3, that's okay except for slenderness. We still are of the opinion that you shouldn't really go for slenderness as over 180, but there's no reason I can't turn around and say I am happy with a lambda limit of 250, and then it's okay because it's a bracing member. That choice is yours and you can set that. I'm going to go for 2 rows of bolts, and we see that it now is well in at that. So we looked at some beams, and if you remember, and I come into planet level 1, we have here a little beam that's got some reversal. I'm going to come along and say lateral restraints. Let me see, axial with moment, not fully restrained, but at 1L. And I'm then going to come along and say that I'm going to restrain just at incoming members. So it's going to restrain here. So automatically incoming members only, and it does all the design for me. So what section is the lightest to work? By weight order, off it goes, and it gives me this section, 457, 152, 52. Now, if we up the grade of steel to 355, how would we do? Because deflection is not a problem, and obviously it's not that happy with anything less. Did I mustn't have set it. There we go, 45 kg in the grade S355 is a solution for us. So that's a bit of steel design, all integrated. Am I going to save these? No, I won't, and there's a very good reason for that. If I save them, I'd have to reanalyze. So what else can we do with this lovely little frame? And come back out to full frame. So we've now looked at steel design. We want to continue the steel design and come into my connections. So I'm now going to look, and actually some connections have already been designed. I'm going to add in a new beam eaves connection, and I'm going to choose this rafter here. So blue screen, blue screen. One of the things you'll find in MasterSeries is we like colors, and colors tell you answers. Blue screen here, I can see that my bolt is too close to the bottom, so go to my second row tab and I will make that 100 mil up, and it's still just saying you may not get that bolt in, and we'll make it 110 and it's happy. Now I've got a little X here, it's telling me that my bolt cross centers, and I can look at my dimensions to see what my errors mean, and I can see what my problems are. In this case, it's just telling me that my bolts here were too close. So back out to the first page, bolt cross centers 54, I'm going to go for 70. Would I get away with 90? No, or 80, too wide on those narrow flanged column beams. So 70 mil cross centers. Now, dimensionally it works. Capacity wise, it is not working. We're 85% overstressed, but we're being told we have a problem here. Very simply coming down, a bottom stiffener of 10 mil. We're now down to only 10% overstressed. The bolts are the failing problem. Let's give it another row of bolts at 90, and that joint is designed for that loading case. Let's see if there's any other failures for this case. So just scan through and say, yes, well actually when we get to this next row of bolts, it's giving us a problem. And I am going to put in another row of bolts and see if that relaxes the load. It doesn't. I'm going to need to put a capping plate in here. And I go to plates and put in a wee 10 mil capping plate, and that should solve my problem. Column tension stiffener and bolt row 0. I don't believe that's actually a problem. Column tension stiffeners. I don't believe there is a... Oh, this is in reversal. Yes, that's what it is. It's in reversal. So I wasn't reading, I wasn't thinking, and it's actually this needs to be a bigger stiffener. That's what the problem is, to work and close that down. So you don't need that, but I actually think sometimes a capping plate is a good thing. Keeps it nice and tight and conventional. So scan again, and now we've been told that we have a problem in loading case 6 with the column stiffener, and we need to possibly get a bigger weld into that, and I'm just looking at it, 7 mil weld. Let's put in an 8 mil weld and see if that solves that problem. It's because it's only welded on one side, because it's a capping plate, we're going to put a 12 mil weld in and possibly put it up to a 12 mil plate to satisfy that, and now that joint's working. Very quick, very simple design of your connections. One more connection before I leave you. Add another joint. We'll do a base plate. Very simple. Coming down to here, and equilibrium. We need some concrete. So concrete grade, we're going to go for grade 40 with a 30 Newton grout, and it's just telling us in here to make sure we use a high strength grout, which I'm happy with, but everything else in fact in this case is okay. So I could probably come down to a 25 grout and it will be happy, and a 30 Newton concrete. Now we need a bit more area around our base, so we just expand the length from 420 to 450 and it's happy. It's now got enough area to get the strength it needs, and it's 195. I'm going to make that 200, and I have got a joint that works. And I can go through the loading cases manually just to make sure that I have no problems, and that's my joint done. So fully integrated design of my joints. I'm going to print those out. It'll not take a minute. Print all of them. Yeah, why not? Or no, we'll just take the two that we did now. We'll ignore the others. These are the two that we did. Full output loading cases, the standard ones, and I'm going to print to my printer, and I'm going to print, and we're now from 32 to 40 pages, so 8 pages of connections, and say yes. So now finally what's left in this frame? Concrete. We said it's a fully integrated system, and it is concrete design. I don't know what the loading in this frame is like. I'm not claiming that. I can say yes. And I can see a nice little simple design with very little beams on it, bars on it. So in this case, the members aren't loaded heavy enough because it was just a geometric example. I'm going to pull in a more detailed example in concrete. So frame, open, and go into my concrete example. Very nice plain frame with columns moved all about the place. Analyze, space frame, graphical, bending. So we have maximum moments on all spans, but we also then have minimum, maximum, minimum, and maximum, minimum, maximum, and then the serviceability equivalent. So we have all our loading cases with our combinations. In this case it is actually 25950 rather than the Eurocode. In fact, 8110, I apologize. So let's go in and do the design. Concrete design. Yes, I'm happy. And we can see our beams, our nice big super member with our stepped reinforcement. So capacity, an anchorage, capacity to here, and then another anchorage, and our nominal steel. So very, very efficient. Again, I don't want to go into too much detail in any one program. I think that MasterFrame editor was worth the additional detail, but we can do T-beams, as you can see. We can do inverted T-beams with bottom loading, so that we're actually, in this case, if we look at our results, we are looking at the torsional design and the torsional load onto the member. So there's just not enough reinforcement in one area that we need to look at. But the nib design's all okay. Additional force, the main links, tension, capacity, everything there is designed, and then the additional moments with our reduction in our steel because of the torsion, all included. And what can we do with this? Very simply, we can print it all out. So let's go and print our results out. Print all design output. Yes. And we'll just take everything. It'll not take too long, says I. And out we go. 40, 50, 60 pages, 70, 80, 90, 110. So that's it done, with some warnings obviously because we didn't actually design all this. And we can also export as a DXF file our details straight through into, in my case I know where AutoCAD is, I can load AutoCAD, so I'm going to export the DXF file. It's loading up AutoCAD 13. Because it's a pure DXF file, you could bring it into any CAD package that you have. because obviously, obviously AutoCAD Lite, being a registered developers, we'd have to say that, but there are other CAD packages available that will read the DXF style. We have got all our beams nicely detailed up for us with all our columns, with all their splice bars. In this case, we asked for splice bars rather than starter bars. I think we put splice bars in because we were changing in width as well. And then you have your pad foundations all detailed up for you in AutoCAD. So that's the concrete design. So we've done steel, we've done concrete, we've done connections. Timber is very straightforward. If you go back to my original frame, we will see that the design of timber is very, very straightforward. If you've got the right loading and the right structure and the right section sizes. Analyze. Just dead plus live. Why are we in a space frame? Okay. He must have put a loadout of plane or something in this frame because it required a space frame. Design timber. And we can then take a look and we can see in this case this member is overstressed. Materials, was it a question of going up to a heavier grade? Not really, that's going to take you way out of beyond. Is it a question of going for a larger size? A 44 by 70, a 44 by 97, a 44 by 122 in a regularized section works. And we can run through and automatically check out and design all our members. So it's running through, having a bit of fun. There mustn't be a design check applied on that one, and we now see all our designs that have been done, and we can see the sections that it has now decided that we will use. And that was how quickly it ran through and sized all those lovely members for us without even thinking about it. Timber design done. And I'll just save that, why not, for the next time. Okay, before we leave frames, I'm going to have a very, very quick look at portals, and then we'll talk about the additional programs. So here's my little portal. In Masterport, let's go into the editor. You have the ability to put in up to 3 spans. Really, you could go bigger, but that's the full version. The PowerPad version allows you 15 members, which is going to get you 3 spans. They can be asymmetrical, they can be monopitch. So I could say yes, it is monopitch, and then I could say yes, it's a mansard of 3 meters, and then that will give me a mansard location. Or if it's not mansard, obviously you can't have a monopitch mansard. You could come in and you can then define your spans. That I say 2, I meant to say yes, and then go to your columns and define your second column, which obviously cannot be fully symmetrical, and then it's taking it up for us automatically. And there's our portals. We can handle base fixity. If I come back to my spans and I say no, and I'm going for some pretty standard section sizes, 406, 356, and general, come out of this, analyze the frame, yes, plastic, plain frame, off it goes into design. And this is where we really get into the plastic. So we will want to first of all set up our parameters, then go through and auto size lightest, and I'm going to say auto size, and it's going to run through and change my section. So now what's it telling us? It's telling us that everything works fine, we just need to restrain our members. So I can come in and do an auto restrain on that current member, and it's automatically tried to strain it up. But I think I have overcooked my books a wee bit here on this frame. There is separate webinars on Masterport. Like all the other programs, obviously we're just giving you a glimpse of what is in PowerPad. Okay, that's the integrated programs. We also have 3, or is it 4? I think it's actually 4 standalone programs. Very simply, masonry design. This is going to take 3 minutes. Demo. What can we do? Well, first of all, let's get a picture. We can do a freestanding wall with piers. No problem in this case. Big problem, it's falling over. We can have two-way spanning. In this case, you would probably come along and say, well, it's going to be 2 meters high. And no, we will not have piers, but we will have 2 panels. So it is a 190 inner and a 102 outer, and it's working in this case to the Eurocode 1996 or Eurocode 6. We can do vertically spanning. We can also do columns. So we could create a wee column of a simple size and off we go. Now, what can we not do? Because we said that these are smaller versions. In the frame analysis and everything, it's very simple. You're up to 100 member limits in your PowerPad Plus. In the masonry, we do not have openings. We cannot do openings. We do not have bed reinforcement. But other than that, for simple laterally loaded panels and vertically loaded panels, we have no problems whatsoever. So we can come in and put in some additional loading. So we can put in our loads of 246 kilonewtons, and it's overstressed by 5% the column capacity, and 125 kilonewtons with our normal eccentricity. So we're overstressed. We either need a bigger blocks or we need a bigger block of block. So a 440 square is not enough. Would we get away with a 625 by 525? I can't even remember my masonry dimensions. That are probably wrong, but that would work. Or 440, if that needs to be the size, we can come in and play around with our other data, such as what is our categories, what is our strength. So let's get up there. If we use 22 or 25 or 30 Newton units masonry, away we go. We can resist that loading and we're happy. So that's the masonry. Very straightforward, very simple. Second, retaining walls. Again, very straightforward. Okay. A masonry stepped wall with cladding. We are not talking about cavity filled reinforced. The cavity filled reinforcement is only available in the full version of retaining walls. So let's get back to the start. Let's take off the stepping. Let's take off the outer leaf. In fact, let's take off the masonry, make it concrete, and we're now happy. We've got a masonry wall. We will make it 200 wide, and it has got a 200 depth with an 800 upstand. We're putting a 0.5 kilonewton wind on that upstand. Soil, we have all our standard front and back soils. What we do not have is layered. That is not available to the PowerPad version. We don't have additional loads. We have our basic loads. So we can have surcharge and wind upstand. I'm going to make that 1.5 because it's going to suck and blow. So it doesn't make that much difference compared to the soil. The reinforcement, then we can size it up and see what we come up with. And it's coming up with 10s at 175, with 10s at 300, etc. And everything's designed. When I'm designing, I normally actually start from here and I take my size right in until it fails, and I say, right, geometrically, that is how big I want it to be. We'll just do that to make it a 2.5 meter long base. Now I've got it structurally sized, and then I'll go into my reinforcement. We've got our water table, as you'd expect. So what is missing in this that you'd have in the full version? Very, very simple. What is missing is reinforced masonry. What is missing is layered soil. What's missing is additional line and partial loads up the back of the soil, or even out here as an additional load causing havoc. And also what is missing is highways. We are unable to do highways, but we do have BS and we do have Eurocode design, and in fact you also have the old Irish standard as well, 325 for masonry, and we do have masonry and concrete, just reinforced masonry but on reinforced concrete but on reinforced masonry. So great little program. You can even do gabions if you want, and I will say okay to that. Third program, composite. Very simple. Primary and secondary beams are available as part of PowerPad. A secondary beam, 9 meter span with 3 meters either side. If I move on to brief 2, a secondary beam, 9 meter spans and 9 meter between them. I could actually make that primary beam 12 meter spans. So that's 12 meters, and off we go, and we design her up. And like every other program in the system, we have the ability to automatically size most of our designs. So a 533, 312, one of the new sections, at 272. That is in grade 43. Let's go up to S2 355. Resize. And 182 kilogram with a different configuration of studs. We can have no openings because that is part of the bigger version, and no additional loads. But we can play around with our studs and our mesh till our heart's content. And that is the composite design. Very simple, very straightforward. In you go and do it. And finally, design wise, pile caps. We just give you a taster, the very popular 2-pile pile cap. We don't allow you to do any more than 2 piles with the PowerPad version. If you want 3 to 9 piles, you need to upgrade to the full version. So that is mainly all of the PowerPad system here. What's it give you? It gives you a rapid design turnaround. It is a very efficient piece of software for designing frames and retaining walls and masonry and timber and concrete and steel. So you have this economical design that gives you that competitive edge. And it's a very professional set of programs and gives you detailed output. So that is the PowerPad. Now there are 3 different versions. So copy the price list. It lists here 2 different programs, PowerPad and PowerPad Plus. PowerPad and PowerPad Plus both give you a 100-member frame analysis, but the steel, concrete and timber in the basic PowerPad are limited to 15-member frames. It's the 100-member frame version, the PowerPad Plus, that is our most popular by far. You can upgrade from one to the other at any time for the difference in price. And just to give you put it in context, if you're buying these 19 different programs individually, you'd be talking about 12,000 quid. So we have these limitations on them all. So in fact, we sell also something called PowerPad 300 that gives you 300-member steel and concrete design and frame analysis for, I think it's 3250. It's a special offer that we do on the PowerPad. So there are 3 different versions of the PowerPad system for you. As I said, this price list program, it also gives you the truth. What does the additional program give you? Well, in frame analysis, it's just more members. In steel design, it's just more members. If we look at the masonry, it's bed reinforcement and openings, as I was saying earlier. If we look at the retaining walls, it is reinforced masonry. it's additional loads. Props and ties, we never talked about props and ties. Layered soil and highways. So those are your additional facilities that are available in the full versions. As we can see from this table also, when you buy a PowerPad version, if you decide to upgrade to the full version, you pay a considerably discounted rate. So instead of paying £1,000, you pay £700 for the composite. Again, for the retaining walls, that's a reduction of £300. And if you add all these up, these reductions, you're going to end up getting far more reductions than the cost of PowerPad. And it's one of the reasons why if I was ever quoting somebody the full version of the full suite, I would actually include PowerPad because it gives you more discounts than it costs. So I'm going to have a quick look here to see if there's any questions that you want. But before I do that, there's one thing that just sprung to mind. Two things, in fact. One was PowerPad can import DXF files. And I did this earlier today. If I come down and find in my demo directory import files, there's a little frame with floors, and it's going to find me all the members, bring them in, and it's splitting the members up, and it will allow me then to load that. Now in this case it is more than 100 members, but I'm just using this frame as an example for you of how you can bring in your basic information. Very, very simple. And the last thing I want to show you before I answer the questions is very important, I think, in this day and age. It's the customization for different national annexes. If you go to design codes, we have the ability to create and edit additional design codes. So I can go to the Eurocode for Ireland and I can say, let's look at concrete structures, and I can change my bearing alphas or my gamma C if I so desire, or my K deflections. Now most of these will usually be the same as the basic one. So you can go in and you can create. So I can come in here and say, right, I want to take a version for Sweden. Have I spelled Sweden wrong? And I'm going to copy it from the defaults, the Euro norm. So I now have a new list for Sweden, but with all the standard values. At this point, I would come along and change my values. There are none in there. Partial load factors, and I'm going to change my squiggle factor to 0.95. So I'm not going to take the 1.25 in my dead loads. I'm going to take actually make it 1 and make it 1.35 and say OK. So I now have a modified section. So now, ladies and gentlemen, it only leaves me to say thank you very, very much for attending. All the best now, and thank you.